Good evening, everyone. This is Neo Ngobeni. I'll be tutoring your physics paper 1 for grade 12. There's not much I can say about myself. I can say I matriculated the year 2024 NSC, and I'm currently studying chemical engineering at the University of Johannesburg. So let's get into business. Today we'll be doing vertical projectile motion, which is your question 3 for your exam. This problem is from the question paper, Gauteng question paper, prep examination 2024. Well, let's start here. Since in grade 12 you only deal with the x and y axis, when we do vertical projectile, we are talking about only the vertical motion, which is the y-axis. So what's important for you to know about vertical projectile? You have to be very careful with the signs because that's where most of you flow. So here is what you do. Once you have your up as positive, automatically downward motion will be negative. So that's all that you really need to know that makes most of the people fail because those are slight mistakes. Okay, let's get into the question. Question 3, a tennis ball falls freely from rest. So already when they say from rest, it means our initial velocity from rest at point A. So our initial velocity at point A, which is here, would be equals to what? 0 meter per second. And which is what we know about free fall, when something falls, not something that is dropped or like projected. So it will be 0 meter per second. So, okay, I cannot write the SI units there because of this pen. So, which is 44 meters above the ground. We are given the distance from the ground to point A to be 44 meters. The time taken to fall to the different positions. So what happens here? The ball will fall from point A to D. It doesn't mean it will stop at B, stop at C. No, they're just referencing they're just pointing out those points that from A to D, obviously it will undergo point B, point C, which are different positions at different time, and the velocity will be different, obviously. So it's given in terms of t. So the time is given in t. So it doesn't mean we know the time. When it's 2t, it doesn't mean 2 seconds because you know that we, in our vertical projectile, we deal with seconds. So now what happens here? The time from A to B is 2t. From B to C, it's t. And from C to D, it's 3. So let's say, for instance, if t, for instance, if t was let's say if t was equals to maybe 1 second, yeah? If our t was, hey, this, get this. If our t was 1 second, let's say our t is 1 second, that means from A to B, it will be 2 seconds. From B to C, it will take it 1 second. Then from C to D, it will be what? It will be 3 seconds. And from A all to D, it means our time would be 6t. If our t is 1, we are just assuming so that you guys understand that that 2 doesn't represent the seconds. It just represents a variable. It's like maybe when they say 2x, x, and 3x. So let's now get into the questions. 3.1. Define the term free fall. Free fall is the motion of an object when the only force that is acting on the object is gravitational force. I don't know if you also define it in that way, but it's best for you to check your exam guidelines for definition so that you don't get anything wrong. Let's get to 3.2. They are saying calculate the value of t. What is t in here? T represents time, but it's not really the time taken from A to D. So when they say t, the best way for us to get t, we can use, which formula can we use? Let's use this formula. Delta y would be equals to vi, which is our initial velocity. Please don't judge my handwriting because I'm not even using my hand. If it was my hand, trust me, the handwriting would be very perfect. Plus 1 over plus 1 divided by 2a change in t all squared. Now, what is our change in y? Firstly, let's take our direction. Since the ball starts at A going down, let's now take our, let's say we take down as positive. Let's take down as positive. With me, I usually take the initial direction. So I'll take down as positive. So now here it will be positive 44 meters. Representing what? This distance. Would be equals to what? What is our initial velocity? At point A, the velocity at point A is our initial velocity. And we know that it was from rest. So our initial velocity would be 0. Then the change in t from A to D, it will be 2t plus t plus 3t. All will be what? 6t. You guys will listen to what I'm saying to avoid confusion with the handwriting because I'm not used to this pen. Then this is divided by 2. What is our A? In this case, acceleration will be positive because we said we are taking down as what? As positive. And acceleration always goes down. Then it will be 9.8. Change in t is 6. T all squared. Now we should get t squared. You can type it in your calculators. T squared should be 44. Oh, this pen needs someone who's very patient. 44 all over. I'll just say 1 over 2 is 0.5 to avoid. It's 0.5. All multiplied by 9.8 times 6 squared. 6 squared. Type it into your calculators. So let's just get the value of t. So put it in a square root so that we just get that the value of our t. T would be equals to, if you type it in, t would be equals to, with the calculator, can I use a calculator? Yeah, let me use this one. So if you type that in your calculator, you'll find that your t will be equals to 0.5. 0.499. So since you guys are told to round off your answers to a minimum of 2 decimals, let's just take 499 because 50 would be 1 decimal. So let's just take 499. Or one can also take 0.5. It won't give like any huge difference. But rather make it 50 or 499 seconds. That's t. So this t doesn't mean from A to D it traveled for 0.499 seconds. It means The value of t, as I said, this could be 2x, 2a, 2b, anything. So it means here it will be 2 multiplied by 0.5, which is 1. So it means here, basically, the time that was used was 1 second. From then here, it's also 1 second. It's 0.5, my bad. 0.5, if rounded off, or 0.499. So I'm just avoiding the decimals. 0.5. Then here, when you say 0.5 times 3, it will give you 1, 1.5. Oh, yeah, 1.5, something like that. So the time total, when we combine all of this, it will give us 2 plus 0.5, which is 2.5 seconds from A to D. Now, our question 3.3, 3.3, yes. Calculate the height of the ball at point C. So at point C here, what's the height at point C from the ground? So since we know that from A to D, it's 44 meters, obviously we should get a height that is less than 44 meters. So what do we do now? If we were to calculate from C to D using this time, we don't have the height, that's what we are looking for, and we don't have the velocity at point C, and we also don't have the velocity at point D. Remember, at point D, the ball strikes the ground. It doesn't stop. So it doesn't mean our velocity at D would be 0. Our velocity would probably be something way greater than 0 because it traveled for 2.5 seconds. So now what we can do, we can get the distance from A to C. If we get the distance from A to C, for us to get this one, we will then what? Subtract this one, AC from AD. So we can say the change in Y, change in Y would be equals to VI, would use the same formula, change in T, oh guys, can I please skip the formula because I'm having a problem with this thing. So let me just skip the formula. We are using the same formula. So our VI from point A to C, it will be, the VI would be 0 since it's from point A, and we know that point A is our reference point where the ball was from rest. Then the change in T from A to C, it's 2T plus T. So it would say this would be 3T, and our T is 0. Oh, that's the 3T. Let's just say 1.5, as I said. Our 3T would be 1.5. So let's just substitute 1.5. You can multiply your 3 by T, which is 0.499. You get a value that is close to 1.5. Plus 1 over 2. 1 over 2. What is our A? We don't change direction. Since our A is positive from the initial calculation, we keep it positive whenever it's going down. So now, our change in T would also be 1.5 all squared. If you punch that into your calculator, what do you get? So now it's 1 over 2, 9.8, 1.5 squared. We get 11, 0, 2, 5. This is in meters. So this 11.025, it's the distance from here. Let me use a different color. We use a different color. So from here to C, it's 11.025. So from A to D, we all know that it's 44 meters. Now, from A to C, we get 11.05. So our height at point C, the height at point C will then be equals to 44, 44, for that, 44 minus 11, 0, 2, 5. Now, as I said, the value should be less than 44. So we subtract it from 44, which is what we know. Then our answer should be, I bet, our answer should be 32 when 9, 7, 5 meters. So this is 32.975 meters. That's the height at point C. Then, if after the first bounce, the ball reaches point C, for those who used 0.499, you'll have a different answer, but the answer can be far from 32. It can be around 31, but that's the range from at least 31 to 33. Not 33, from 31 to 33, yeah, to 33. Then, if after the first bounce, the ball reaches point C, sketch the position versus time graph for the ball from the moment it is dropped. So from the moment it is dropped from A to when it reaches point C, but you can see there. So show the following on your graph. The time value of D, show the time value of D and C before the bounce in terms of T. So it should be in terms of T. Okay. The height at point C, the height at point A and C, okay, take the ground as 0 reference. Okay, so if they say take the ground as 0 reference, you'll see on the sketch, that's how we'll take it. So this is what happens now. My teacher taught me that whenever they say, you see on this graph, whenever they say draw a graph of time, of velocity versus time, your heading, it's now velocity versus time. It's easy with physics. So now here, our heading would be, they said it should be sketch the position. So it's position, you will write it position. I'll just say position versus change in time. Let me just say change in time. Okay, so this is my graph. You should understand that my handwriting won't be good because of this. So this would be my change in Y, right? This one would be my change in T. So what you know about something that is falling, okay, this would be our, we just do this. Yes, from here, the ball will fall going down. So there is no way that we will say the ball will go up a bit. So with this one, you take it from here, going down, then later the gradient becomes steep. Because remember, with projectile, When something falls, it starts at zero, but later on the velocity would be higher. So at somewhere here, you'd find that it's at point C, as they said. Look at that. From point A to B, can you see that gap? It says the ball covered a long distance for 2t. Then from B to C, that short distance for 1t. Then from C to D, that's a long distance, 32,975 meters, was covered in only 3t. So that shows that from C to D, the ball was now moving very fast than from A to B. So this shows that the gradient is now steep, showing that the change in displacement now decreases at a rapid rate. From here, the ball was said to bounce. So let's just take it up a bit. Then we have to indicate this to be our point C. At point C, it's 32.9725. Please note that. Then what did they say we should show? The time values at point D and C before the bounce. So let's say this would be our C. This can be our C. And at point C, what's our time in T? From A to B, it's 2t. From B to C, it's t. So now at C, what do? We add 2t plus t because it's the time taken to travel from A to C. So this will be our 3t. My bad. This will be our 3t. And this one is our D. The time taken to reach point D in terms of t, it's 6t because we add all those t's. As I showed you on the calculations that I added the t when I was using 44 meters here. Then what do they want? The heights at point A and C. C we already noted. Then at point A, the height was 44. We were given this height at point A. Okay, this is what. Then what? Take the ground as zero reference. Taking the ground as zero reference, it's this because you see, when it hits the ground, that's what we indicated at zero. That's what they meant. And if you have any question, you will comment. And if there are any things that you think I should also touch on or anything